Our next type of problem that we want to solve, and the last three types of indeterminate forms, are indeterminate powers. That is 0 to the 0, infinity to the 0, and 1 to the infinity. Each of these problems work pretty much the same way. We want to set up our limit, so if we have an indeterminate limit like this, we want to think of it as y equals this limit, and then use the natural log of both sides in order to get at the power, change the form into a different type of indeterminate limit, and then use L'Hopital's rule once we have a 0 over 0 or an infinity over infinity. So let's take a look at an example. This is pretty straightforward. Clearly 0 to the 0 indeterminate form. So we call this limit y and use the natural log of both sides. If you call from the section on properties, we can bring the natural log inside here. And now we have properties of natural logs, which allows me to bring the power down to make it a product. Now, this changes the form of the indeterminate form from infinity to the infinity to 0 times infinity. In this case, 0 times negative infinity. Well, that is not L'Hopital's rule yet. We need to make this 0 over 0 or infinity over infinity. So what we can do is what we did last time. Change this to a fraction, and the most convenient part to bring to the denominator would be the x. Now this looks familiar. We did this problem earlier. The top is going to negative infinity, the bottom is going to positive infinity, and now we can use L'Hopital's rule. Using L'Hopital's rule, taking the derivative of the top, we have 1 over x, which is x to the negative 1. Taking the derivative of the bottom, we have negative x to the negative 2. And this, we already saw, we can simplify as negative x to the positive 1 after bringing that denominator to the top. And this has a limit, and the limit is 0. But what we just found was the limit of the ln of y. In order to go back to y, we need to exponentiate, and the ln, e to the ln of y is just y, and e to the 0 is 1, which gives us our limit.